This problem is number 24 from the 2008 AMC8 math competition. And I like this problem because it seems like it should be easier than it is. Because problems like this often are pretty easy, but it really isn't, and it takes some good thought to go through and do it. The first thing we say is we've got really two scenarios that are happening. One is picking a tile. The other is rolling a dice. And so the number of ways we can pick a tile and roll a dice is just the number of ways we can pick the tile, the number of ways we can roll the dice. And so our denominator is 10 times 6, which is 60. So we know our answer is going to be out of 60, even though it might be simplified, so that doesn't really restrict any of the possibilities. So now we've got to think about how many ways can I take a number from 1 through 10, multiply it from a number through 1 through 6, and get a perfect square. Well, the first ways to do it is to pick the same number for both of them. And there are 6 ways to do that, right? All 1 times 1 through 6 times 6. And so we know there are 6 ways to get a perfect square. Those are the easy ways to do it. Now we got to think of the other ways. So what I'm going to do is I'm going to start with the dice, and I'm going to say, I'm going to figure out ones, kind of use a stem and leaf plot here type of look, that if I pick a 1 with the dice, what things can I multiply by it to get a perfect square? Well, if I pick the dice as 1, then if I pick a 4, if I pick any other perfect square from the 10s except for 1, because I've already counted it, then I'm going to have a perfect square. So I could pick 4, or I could pick 9, because 1 times 4 is 4, 1 times 9 is 9. Those are both perfect squares. So that gives me 2 more from the 1s. If I pick a 2, well, it may not be as obvious what this one is, but the first thing is I know that it's got to be an even number. And I know that the biggest it can be is 20, because 2 times 10 is 20. Well, the only even perfect squares less than 20 are 16 and 4. Well, I've already counted 4 right here. But I can do 16. 2 times 8 equals 16. And so that's an additional perfect square. If I look at 3, well, now I've got to do multiples of 3. Well, I've already done 9. And 3 times, and so I've got to look for multiple of 3 perfect squares less than 30. Well, the next multiple of 3 perfect squares is actually 36. So there are no ways to do it with a multiple of 3 on the dice. If I look at 4, I can't forget that 4 times 1 works for the same reason that 1 times 4 works. I've got to count 4 times 1 because that's a perfect square as well. And then the other one is I got to look at perfect squares that are even, but this time less than 40 because the biggest I could have is 4 times 10. Well, I've already checked 16 because that's 4 times 4. I can't get 4 I've already done as 4 times 1. So the only other one is 36, and that does actually work, which is 9. 5, the only possibility is 5, so that doesn't work. And then 6, well, it's got to be a multiple of 3 and an even number, and the only one of those is 36. It's less than 60. The next one would be 144, and so that's not possible. So none of those, and so I add 2 for my 4s, and I end up with 11 over 60. So there are 11 over 60 ways to get a perfect square when you draw a number from 1 through 10 and a number from 1 through 6 and multiply them together. Definitely a little bit harder than you initially expect it to be.